You ever feel like you're drowning in information, especially when it comes to tech stuff? Like you just want someone to cut through the noise and tell you what really matters.
I know exactly what you mean, and that's exactly what we're doing today, diving deep into software testing metrics.
Ah, yes. Software testing metrics. Sounds kind of, well, technical, right?
It can be, but it doesn't have to be. Think of it this way. These metrics are like your dashboard for a software project, telling you if you're speeding, low on fuel, or about to crash.
Okay, I like that. So we're
Yep.
talking about understanding how healthy the project is, how efficient the testing is, and basically how good the software is going to be in the end.
Exactly. It's all about getting a clear picture of quality, moving beyond just gut feelings and guesses. And the great thing is, the material we've been looking at lays it all out in a super practical, step-by-step way.
That's what we like to hear. So today, we're on a mission to break down these essential metrics and make sure you walk away feeling confident about what they mean without giving you information overload.
That's the goal. No mental marathons here.
So where do we begin? Well, the research actually points us to a spot even before any testing even starts.
You're right. It all begins with test planning, that crucial groundwork that sets the stage for everything that follows.
So it's like before you even hit the gas, you got to make sure you've got a destination in mind, right?
Precisely. And the first landmark on our roadmap is the total number of requirements.
Okay, break that down for me. We're talking about everything the software is supposed to do, right? Like a complete list of its functions and features.
Exactly. The material gives us a nice simple example. Let's say there are 5 requirements. That's our starting point, the scope we're dealing with.
5 requirements, got it. But how deep do we go with testing each one?
That's where the next metric comes in. The average test cases per requirement, or TCR.
PCR, catchy. So this basically tells us how detailed we're going to be with our testing for each of those requirements.
Exactly. The example we have uses an average of 50 test cases per requirement. Now that suggests a pretty thorough approach, doesn't it?
50 for each. Yeah, that definitely paints a picture of some serious testing going on.
And if you multiply those two figures together, the 5 requirements and the 50 test cases per requirement, what do you get?
Well, that would give us a grand total of 250 test cases.
Bingo! That total test cases number is like your testing budget. It tells you the size of the mountain you need to climb and helps you plan out how much time you'll need, how many testers, all that good stuff.
So we've got the plan, we know what we're testing, and how much testing we're doing. What happens next?
Well, then things get real. We shift gears into the test execution phase.
This is where the rubber meets the road, right? Where we actually start running those tests.
Exactly. And as we're running those tests, we need a way to keep track of how we're doing. Enter the test execution percentage.
Okay, so this tells us how much of that testing mountain we've climbed so far.
Right, and the formula is pretty simple. You take the number of executed test cases, divide that by the total number of test cases, and multiply by 100.
So in our example, we've executed 200 out of those 250 planned tests. So 200 divided by 250 times 100, that gives us 80%.
80%, meaning we're well on our way. And naturally, that also tells us how much is left to do. That's where the unexecuted test case percentage comes in.
So just a quick 1% minus that 80% test execution leaves us with 20% of tests still to go.
And this is really helpful to see where you stand and how much work is still ahead. Now, there's another metric in this phase that I find particularly fascinating. Testing velocity.
Velocity sounds like we're talking speed here. How fast is that testing team cranking through those tests?
It's exactly that. Testing velocity measures how many test cases the team can execute in a given time frame.
So how do we calculate that?
You take the number of executed test cases and divide it by the total time spent on execution.
In our example, we had 200 executed test cases, and it took the team 60 hours. So 200 divided by 60 gives us about 3.33 test cases per hour. Okay, that gives us a sense of their pace.
Yeah.
But how do we use that practically?
That's the beauty of velocity. Once you know how fast you're going, you can start predicting when you'll reach your destination. It helps you figure out the estimated time to complete testing.
So you're saying if we know we have 50 test cases left and our velocity is 3.33 test cases per hour, we can estimate how many hours it will take to finish.
Exactly. In this case, it would be about 15 more hours. Now, why is this important? Imagine you have a big marketing campaign launching, or a competitor is releasing a similar product. If those 15 hours push you past a critical deadline, it could have a huge impact on the business.
So it's not just about the numbers, it's about understanding the real-world implications.
Absolutely. Knowing if you're on track or not can make all the difference. Now, so far we've talked about planning and execution, But what about the bugs?
Yeah, we got to find those pesky critters hiding in the code. That's where defect identification comes in.
That's right. This phase is all about analyzing the problems we find during testing. And the most straightforward metric here is simply the total number of bugs.
So we're counting how many bugs or defects we uncover.
And the material makes a really helpful distinction between internal bugs, those found by our testing team, and external bugs, the ones that slip through the cracks and are found by users. Ouch.
Yeah, those are the ones we definitely want to avoid.
For sure. In our example, they had 20 internal bugs and, unfortunately, 5 external bugs. That gives us a total of 25. Now, this number by itself can give you a general sense of how stable the software is.
Okay, so 25 bugs. But is that a lot? Is that normal?
That's where defect density helps us out.
Defect density? It sounds kind of scientific.
It's a way to evaluate the quality of the code in relation to how much testing we've done.
So it's not just about the raw number of bugs. It's about how many bugs we're finding per unit of testing.
Exactly. You calculate it by dividing the total number of bugs by the total number of test cases.
In our example, 25 bugs divided by 250 test cases. That gives us 0.1, which translates to 10 bugs per 100 test cases.
Right. Now that 10 bugs per 100 test cases gives us a more normalized view. But the question then becomes, how does that stack up against industry benchmarks or past projects? Is there a threshold where, regardless of the number of tests, a certain defect density should raise a red flag?
That makes a lot more sense than just looking at the raw number. Now, speaking of red flags, those external bugs, the ones found by users, those are the ones that can really hurt, right?
Absolutely. That's why defect leakage, sometimes called escape bugs, is such a crucial metric. It tells us how many bugs made it past our defenses and ended up in the hands of users.
And the formula for this one.
You take the number of external bugs, divide that by the total number of bugs, and then multiply by 100. So in our example, 5 external bugs out of 25 total bugs means a 20% defect leakage.
Oof, 20% doesn't sound great.
And remember, it's not just about the percentage. Let's say those 5 external bugs affected key features that users rely on. We could be looking at bad reviews, frustrated customers, and even people abandoning the software altogether. So understanding the severity of those escaped bugs is also crucial from a business point of view.
It's definitely a metric we want to keep as low as possible.
Absolutely. Now, there's another aspect to this: defect distribution.
So we're looking at the breakdown between those internal and external bugs.
Right, and this tells us a story about where we're catching those bugs. In our example, it was 80% internal and 20% external.
So 80% caught internally, that's a good sign, right?
It suggests our testing process is working, catching those bugs before they reach the users. On the flip side, a high percentage of external bugs might mean we need to rethink our strategy or focus our efforts differently.
Okay, so we found the bugs, hopefully they're being fixed, and we're approaching the finish line of the testing phase. What happens in the test completion phase?
This is where we take a step back and evaluate the whole process, see how effective our testing really was.
A little reflection time.
We revisit some familiar metrics and introduce a couple of new ones. First up, test coverage percentage.
Isn't it the same calculation as test execution percentage?
It is, but at this stage, it takes on a new meaning. It's not just about how many tests we ran, it's about how much of the system we actually tested.
So did we hit all the crucial parts? Did we cover enough ground?
Exactly. Now let's talk about those bugs we found. We need to know how well the development team is handling them, and that's where defect fix rate comes in.
This is about how efficiently they're squashing those bugs.
Exactly. You calculate it by dividing the number of fixed defects by the total number of defects and multiplying by 100. A high fix rate tells us things are moving smoothly, bugs are being resolved quickly and effectively.
Great. And lastly, the material mentioned retest percentage.
Ah, yes. This one can be insightful. It tells us how many test cases we had to run again after a bug was supposedly fixed.
So a high retest percentage, not a good sign.
Not necessarily. It could point to some instability in the fixes. Maybe they're not as solid as we thought. Or it could mean our initial testing wasn't thorough enough in certain areas.
Okay, so we've covered a lot of metrics. But why should we care about all these numbers? What's the big takeaway here?
You know, the material puts it perfectly. Testing without metrics is like driving with no speedometer. You're flying blind, no idea how fast you're going, how much fuel you have left, or if you're even headed in the right direction.
I'm starting to see the light here.
Right. These metrics aren't just numbers on a page, they tell a story. The test execution metrics keep us on schedule. The defect metrics tell us about the quality of the software. And being able to measure things like testing velocity and estimate the time to complete, that's crucial for planning and managing resources effectively.
It's all about making informed decisions, making sure our testing efforts are as effective and efficient as possible.
Precisely. Now, with all this information, it's natural to wonder, who needs to see all this?
Does everyone on the team need the same level of detail?
Not really. Different folks, different needs. Testers and QA leads, they're in the trenches. They need all those nitty-gritty detail.
They're analyzing everything, looking for areas to improve.
Right. Then you have the developers. They're mainly concerned with the defect-related data. What needs fixing? How do we fix it?
Makes sense. What about the project managers?
They need the high-level overview, the big picture. Are we on track? Are we meeting our deadlines? That sort of thing. And then, of course, you have the stakeholders and clients.
They just want the bottom line, right?
Exactly. Something like 80% of tests executed, 20 bugs found. They need a clear, concise understanding without getting lost in the technical weeds.
So it's all about tailoring the information to the right audience. Now, to wrap things up, what's the most important thing to remember about all these software testing metrics?
That they're not just about collecting data for the sake of it. It's about gaining real, actionable insights. Are we making progress? Are we delivering a high-quality product? Are we making smart decisions throughout the process?
It's about using these metrics to guide us, to make sure we're on the right path.
And ultimately, to deliver the best possible software. So to leave you with something to ponder, think about all the metrics we've discussed and consider this. What do you think is the single most telling metric for understanding the business risks associated with the software release? Go beyond the bugs and the test cases and think about the big picture impact on the business itself.
That's a great question to leave our listeners with. It's not just about the technical side, it's about the real-world consequences.
Exactly. And that's what makes these metrics so fascinating and so important.
Well said. Thanks for joining me on this deep dive into software testing metrics.
It's been a pleasure.
And to our listeners, thanks for tuning in, and we'll catch you next time.